1.04 applications of triangle similarity. We're going to go ahead and prove theorems about triangles. We're going to look at the triangle proportionality theorem as well as the triangle angle bisector theorem and solve problems using both of these theorems. So let's look at the triangle proportionality theorem first. This says that if a line is parallel to one side of a triangle, and intersects the other two sides in two distinct points, then it separates these sides into segments of proportional length. The converse of that statement, meaning that we're going to go ahead and flip that, says that if a line intersects two sides of a triangle and separates the sides into corresponding segments of proportional length, then the line is parallel to the third side. So let's go ahead and prove this using a two-column proof. Now we learned in first semester that there's three different types of proof in geometry that you're going to use. You're going to use two-column proofs, paragraph proofs, and proofs. We will be using paragraph proofs a lot through second semester as your standard-based writing assignments. So it's important to understand how this two-column proof works so that we can turn it into a paragraph proof. In this one, we're given that triangle ACE, and that BD is parallel to AE. We need to prove that BA divided by CB is proportional to DE divided by CD. So we're going to go ahead and throw up this two-column proof here. Notice that you've got the statement and you've got the reasons. Okay, so what we can do is we put in here what is given, and then we walk through how to prove that it's proportional. So we say that angle 4 is equal to angle 1 and angle 3 is equal to angle 2. And the reason that we can say that this is true is because each one of those angles is a corresponding angle. And this is a postulate, so it doesn't have to be proven. Corresponding angles are congruent because I said so, or because math person said so. Now, triangle ACE is similar to triangle BCD because of the angle-angle similarity postulate, meaning that because these two angles are congruent and these two angles are congruent, then angle-angle similarity postulate says that these two triangles are similar. We can then go to the polygon similarity postulate, which says that if CA divided by CB is equal to CE divided by CD, then the polygon is similar. Now we can say that CA is equal to BA plus CB. Now let me show you what that means really quick. So CA is this line right here. And we are saying that CA is equal to AB, so this part of the line right here, plus this part of the line right here. What? No kidding. But we have to put that in our proof. We know that that's true because it's a postulate, but we still have to say that it's true. So we call that segment addition. That just means we're adding the lines together, okay? Now, Since we know that BA plus CB is equal to CA, we can go ahead and say BA plus CB divided by CB is equal to DE plus CD divided by CD. Now you probably noticed something here besides the fact that we substituted. You probably noticed that I said CB and CD twice right here. Well, in that case, when we're adding these together with the addition fraction, all we have to do is say CB divided by CB is equal to 1. That's called simplifying. So now we have that BA divided by CB plus 1 is equal to DE divided by CD plus 1. Subtract 1 from both sides, and we get, there's our subtract 1 from both sides, we get the proof that BA divided by CB is equal to DE divided by CBD, but we never want to say proof. Okay, so our final step is just showing how I did it, and I did it by subtraction in the very end. Nice work. Now let's look at the angle bisector theorem. So the angle bisector in a triangle separates the opposite side into segments that have the same ratio as the other two sides. So here's my bisector, and it's separating these into segments that have the same ratio or the same proportion. You're going to hear ratio, proportion, fraction, all at the same time. You're going to hear lots cross multiply, all those things. So here we're going to use the word ratio instead of proportion. Okay. Now the converse, the opposite, says that if a point separates the sides of a triangle into segments that have the same ratio as the other two sides, then the line segments from the opposite vertex to the point bisect the angle. All right, so let's see how this works. We're going to prove using a two-column proof the angle bisector theorem. We're given triangle ABC. We're told that AD bisects angle A, and we are asked to prove that AB is divided by AC is proportional or is equal to BD divided by CD. And again, we walk through our proof. So here, what we're going to do instead is we're actually going to add another triangle here. So we're going to use the fact that all right angles are congruent to show something. Let me show you what I mean here. So I'm going to pause this one here because I've extended this line out and I've created a 90-degree angle called B prime. And I've extended CA so that it matches. And I can do the exact same thing here. And then C prime is also a 90-degree angle. Now I have congruent angles, two congruent angles, and I can use the angle-angle similarity postulate. This tells me that I can set up my proportions so that AB divided by AC is equal to BB prime divided by CC prime. Using the vertical angle theorem, I can show that angle BDB prime, so that's going to be this angle right here. Let me put these lines back for us. This angle right here is congruent because it's shared. All right, so now we can keep moving through here and we can see that BD B prime divided by C prime is equal to BD divided by CD. We can use the transitive property to show equality. If you have any questions about this lesson, feel free to reach out via email or text.